Hi all, today we will see the addressing modes. Addressing modes are very important in computer architecture. Uh, Before discussing about addressing mode, let us discuss the need for addressing mode. We all know that the instruction contains two parts as of now, but in fact the instruction contains three parts. So far we know that the instruction contains two parts, that is opcode and operands. So remember, they are operands, can be more than one operand. In fact, it can be zero or more operands. So there are certain addressing modes. There are certain types of instructions. There are certain types of instructions where uh, there is no need to specify the operands in the instruction itself. We will see all such different kinds of instructions. But remember, this is the instruction format. This is the instruction format that we discussed, which contains opcode and operands. Remember, operands can be 0 or more operands. And the typical example of any addressing mode is add a comma b. This is an instruction, example of an instruction. Add is an opcode, ab are the operands. But there is lot more there are a lot more things to be discussed about these operands. Why? What do you mean by A and B? We all know that when it comes to operands or data in which this particular add operation is required to perform, this AB, ultimately we should get some values for this AB. That is our goal. And those AB values can be present at different places. The immediate place is the register. So where can we find the operands? Is a big question. So the operands we can find either in the register. So different possibilities are, it can be in the register, or it can be within the instruction itself, or it can be in the memory. So the location of the operands can be in the register, or within the instruction itself, or it can be in the memory at a particular memory location. So these are the different possibilities, three possibilities. So these are the three possibilities where the operands can exist. See, when we want to execute any instruction such as add a comma b, the control unit decodes this opcode add and sends a signal to ALU saying that you require to perform an addition operation. The ALU understands with the signal that is coming from control unit, it has to perform addition. But in order to perform an addition operation, it requires two operands, A and B. Ultimately, it should have get some two values. Let us assume 10 and 5. So what are the different possibilities that this 10 and 5, where these 10 and 5 values can be stored means, one possibility is in the registers, other possibility is in the instruction, and other possibility is in the memory location. So before going to discuss about addressing mode, let's discuss the need for addressing mode. If I say add A comma B can be registers, where the registers directly contain the value 10 and 5. That is one possibility. Or the register can contain these 10 and 5 values can be in the memory. In that case, AB are still registers. Then what AB should contain? Yes, the address of the memory location 10 and memory location where 5 is stored. Are you getting? So let me discuss with a simple example so that you understand the need for addressing modes. Let's assume our memory is divided into, for simple case, 4 memory locations. Memory is divided into 4 memory location 0, 1, 2, 3. So at memory location 10, at memory location 1, the value 10 is stored. At memory location 3, 5 is stored. So these are addresses of these memory locations. So let's assume A and B are two registers. Now when I say add A comma B, we are trying to add the value 10 and 5. So the value of 10, the value 10 is stored at memory location 1. So that register A should contain the value 1. Similarly, the memory location 5, the value 5 is stored at memory location 3. So it required to, this register has to store the value 3. So when you say add A comma B, you are not actually adding the value 1 and 3. No. So A contains address of memory location 1. B contains address of memory location 3. So it requires to take the address of memory location address that is stored in register A, go to memory and fetch the value 10. Similarly, for B register, take the address 3, go to memory location and fetch the value 5. Now you will require to add 10 comma 5. So this is one such example for the need for addressing mode. Then within the instruction, by looking at the instruction, how can the control unit identifies or the ALU identifies where the operands are stored? When you say add A comma B, whether AB are the registers, if AB are the registers, whether they contain directly the value 10 and 5, that is data, or the registers contain the address of the memory location where the actual values are being stored. So these are the different scenarios, these are the different modes for specifying address of operands. So what we understood that, we understand that there are different modes of operands, there are different modes of ways where addresses of an operand can be stored. So this is the need for discussing about addressing modes. So let us discuss a simple case of addressing modes. But remember one thing, what are the possibilities of an operand to be present or to be stored means, one possibility is within the instruction, second possibility is within the register itself. The register can directly contain the value, or the register contains memory location addresses where it is required to perform fetch operation for the memory to fetch those operands, or sometimes the instruction can contain directly addresses. So there are the different possibilities. I hope you are getting what I am trying to say. So there are the different ways of specifying operand values in the instruction itself. That is nothing but addressing mode. First we discuss some introduction. Now we read some details about addressing modes with the knowledge of whatever we discussed so far. The operation field of an instruction specifies the operation to be performed. That is opcode. The opcode part of an instruction specifies what operation is required to perform. Who decodes? The control unit decodes. How it decodes? By using a special combinatorial circuit called instruction decoder. So when the instruction is fetched from memory, it is stored in IR instruction register. In the instruction register, we have an instruction. So the control unit fetches opcode part of the instruction and it decodes it and understand that it requires to perform addition operation, sends a signal to ALU. So that is what he is trying to do. Operation field of an instruction specifies the operation to be performed. This operation will be executed on some data which is stored in computer register or main memory. So the operation will be executed on some data which is stored in computer registers or in the main memory or within the instruction itself. The way an operand is selected during the program execution is dependent on addressing mode of the instruction. So where the operand is, how to select an operand, whether the instruction, by looking at the instruction, the control unit should say that the address of an operand, where the location of the operand, whether it is present in the register, whether operands are present in the register, or the operands are present in the memory location, or the operands are specified within the instruction itself, or operand address of the operands are directly specified in the instruction itself. So there are the different cases. So the way an operand is selected during the program execution is dependent on addressing mode of the instruction. So the purpose of using addressing mode is to give the programming versatility to the user. So by looking at the instruction, one should identify the type of the addressing mode and it should be unique. It should be unique for the total world. Anyone should able to easily identify the addressing mode of the instruction. The addressing mode means the address of the operands by directly looking at the instruction. Second is reduce reduce the number of bits in addressing field of the instruction. So by applying addressing mode technique, what happens, the need for specifying the complete address of an operand gets reduced, or the length of bits required to specify the address of the operands may get reduced. So these are the two important needs for discussing or having addressing modes. Now let us discuss some important types of the addressing modes. In that, the first one is immediate mode. So it is a simple and easy to understand addressing mode. Why? Because in this mode, operand is specified in the instruction itself. So it is one of the simple type of addressing mode. The operand is specified within the instruction. An immediate mode instruction has no operand field rather than address field. So remember, the instruction is available immediately within the address is the address of an operand is available immediately within the instruction itself. So the immediate mode addressing mode or immediate mode instruction has an operand field rather than address field. And simple example for such immediate mode is add 7. So with opcode, one can control unit can decode that it is required to perform addition. And look at the operand field, operand part. It contains only some value 7. And you know that if I want to perform addition, I require two operands. And what is the first operand means? That is the value present in accumulator register. So remember, accumulator register is can be a default operand in this case, because so the instruction should be interpreted as add AC comma 7. This should be interpreted like this. Why? Because the AC is the default register, which is the default operand. AC is the accumulator register. All of you know that AC is an accumulator. It is a special kind of register, and this register is having some value that is the default operand. So, and the second value is 7, which is directly added to the content of the accumulator. So let's assume the accumulator is a special register which contains the value 10. So by executing add 7, the accumulator value is increased to 7. So it is increased to 17. So this is the execution done by ALU. So this type of addressing mode is called immediate addressing mode. And let us discuss some advantage of this immediate addressing mode. It requires very less time to execute the instruction. The execution time get will be much lesser when compared to other addressing modes, because the instruction itself contains the operand, and the one operand, and the second operand is an accumulator. And we discuss second type of addressing mode, which is called register addressing mode or register mode. So in this register addressing mode, as the name specifies, in this mode operand is stored in the register, and this register is present in the CPU. See, the important thing is register mode means one can easily guess that our operand might be present in the register. But the important point is these registers are present within the CPU, within the control unit and ALU. The instruction has the address of the register where the operand is stored. So this is an important. Instruction contains the address. Address means name of the register. Register address where the actual value is being stored. This is called register addressing mode. And by looking at the diagram, you can specify that how the instruction would be. This is opcode part, and this is the name of the register or address of the register. Next, that register is present in the CPU. So go to that particular register. Let's assume if it is R, just go to R, which contains some operand, get the value. So it may take little bit more execution time when compared to the previous addressing mode, that is immediate addressing mode, because the immediate addressing mode, in immediate addressing mode, what's happening, the operand 7 is readily available within the instruction itself, whereas in this case the instruction contains the name of the register or address of the register, so it is required to go and fetch the value that is stored from the register. So this is called register mode. And so in register addressing mode, as I specified, the operand of instruction is stored in the register, and we will mention the name of the register or address of the register in the instruction. So it is an example of second addressing mode, that is register mode. And the first one was implied mode, where the instruction itself was containing the operand value. But in register addressing mode, the operand is stored in register. And we see the advantages and disadvantages of the register mode. The advantage of register mode is that shorter instructions and faster instruction fetch, because it doesn't have any address, it just have the name of the register or address of the register. Length of the instruction would be less. So when the length of the instruction would be less, then you require less time to fetch that instruction. The length of the instruction would get reduced, and with this it is easy, it takes less time to fetch the particular instruction. And the second advantage is that faster memory access to operands, because the registers are the immediate memory locations for ALU and CU. So if the operand is in the register, it takes very less time to fetch that memory to fetch those values present in the operand, rather than when compared to the operands present in the memory location. These are the advantage. The first one is, as the instruction contains only the name of the register, the length of the instruction would get reduced. And the second point is that it is with what happens with when the length of the instruction gets reduced, means it is easy to fetch. And second advantage is that faster memory access to operands. And the disadvantage is that very limited address space, because as we have the limited number of registers, the number of registers are limited in a CPU in control unit, so the address space would be very limited. And using multiple registers helps performance, but it complicates the instructions. So if you try to increase the registers, though it improves the performance, we can't keep large number of registers within the control unit, because it becomes very complicated to manage all those registers. So the number of registers should not be very less or should not be more. It should be optimum. It should be optimum number of registers should be present. The first disadvantage was that the address space was limited, because we have limited number of registers. So if you try to increase the number of registers to increase the address space, what happens? Then managing those registers may become complicated thing. So these are the disadvantages and advantages of. And let us discuss a simple example. Add R1 comma R2. So R1 is the one register name, R2 is another register name. What happens here? The content of, let's assume R1 is one register, R2 is another register which contains 10 and 5. So the content of R1 plus R2 is added, and again results is stored in 2. Why? 2 or 1. So again the results are getting stored in register, because this is a two address instruction. Remember, when we discussing about types of the instructions or format of the instructions, there were different kinds of instructions, like zero address instruction, one address, two address, and three address. And since this is supposed to be a two address instruction, the result has to be again should be stored in one of the register. So this is a simple example for register mode. And Another important type of addressing mode is register indirect mode. So it is similar to the register mode, but it has an extra word called indirect. So with this indirect word, what happens? It doesn't contain the value. With this indirect, one can assume that the register contains a value, but it is not the operand value, rather than it is an address of the operand. So in this mode, the instruction specifies the register whose contents give us the address of the operand. This is important, address of the operand which is in the memory. So the actual location of the operand is in memory. See here, the memory is divided into different parts, 0, 1, 2, 3, and the operand is stored in the memory. Let's assume 10. But what's happening? The address, the 10 operand 10 is being stored at memory location 1. So this 1 value will be stored in the register. So the register 1 contains 1. See, the register contains the address of the memory location where the actual value of the operand is stored. So in register indirect mode, remember one point. First point is that operand is stored in memory. So when I say operand is stored in the memory, it is stored in a particular memory location with specified address, and we know that each memory location has a unique address. So this address would be stored in the register, and this register name is mentioned in the instruction. So this is called register indirect addressing mode. And we from this we can conclude that it takes longer time to fetch the instruction, because first we have to fetch the register value, and with that we have to fetch the actual operand. So in this mode, the instruction specifies the register whose contents given us the address of the operand which is in the memory. The address of the operand is in the memory. Thus, the register contains the address of the operand rather than operand itself. So the register contains the address of the operand but not the actual operand. So this is about register indirect mode. And let us understand the diagram. This is an instruction which contains an opcode and register address, and when the register in the CPU, let's assume this is register R and this is register R, and this register R containing address of an operand, pointer to operand. So when it contains pointer to operand, it should go and fetch again one memory read operation is required here. Take the address 1 and go and fetch the actual operand value. So the first thing is how to specify the instruction. See, in registered mode we said add R1 comma R2. This is the registered mode. In registered indirect mode there should be a way add R1 like square brackets, R2 followed by square brackets. With these square brackets we understand that the register doesn't contain the actual value of an operand, rather it contains address of an operand. This is one notation, this is one way of mentioning. But how the control unit identifies this means, so the control unit identifies with a special field within the instruction. that is called addressing mode bits. So now we understand the importance of dividing the instruction into three parts. One is opcode, another is operand. This is this bit, some 2 bits or 3 bits are reserved for addressing mode. This is important. These 2 or 3 bits are reserved for addressing mode. If it is 00, it may be immediate mode. 01, it may be registered mode. If it is 11, it can be identified by CU that it is a register indirect mode. I hope you are getting the point. So it is better to divide the instruction format into three types and preserve some bits for addressing mode. So this is called register indirect addressing mode. Now we see the advantage. We try to guess the advantage and disadvantage of this register indirect mode. The best advantage is that we have unlimited address space. That is the biggest. The address space now is not limited to just register, but the address space is limited to whole memory when compared to. And we need see it's a 4 GB RAM, 8 GB RAM means address space is not limited. It can be go up to 4 GB or 8 GB. So this is the advantage of register indirect mode. Address space is not limited. See, in the previous case, when we have registered mode, the address space is limited to registers. But in this register indirect mode, address space is limited to main memory, which is large memory, has a large capacity compared to registers. Registers can be at the max 32-bit or 64 registers, some 30 to 40 registers, and it is very less when compared with the main memory, where the main memory is measured in GBs. The address space is not limited. That is one advantage. And the disadvantage, one can easily identify that you require some extra memory fetch for fetching an operands. First you have to go to registers and fetch the address, store the address in MAR, memory address register, go to memory, fetch the value in MDR, and place that in again in the registers. So it requires some extra hardware in terms of cost. So it requires some extra hardware, and also it takes some extra time compared to register mode or immediate mode. So it is a complicated from hardware point of view, and it takes more. The execution time or fetching time of an operand would be more, so the execution time of an instruction also gets increased. But the advantage is that the address space is not limited. Next we see another addressing mode, that is auto increment mode and auto decrement mode. It is very simple addressing mode, auto increment and auto decrement. In this, register is incremented or decremented after or before its value is used. So it's a very simple addressing mode where it's, if you mention this addressing mode, what happens, the register value is getting incremented or decremented before a value or after the value is. This is used for, I hope by you understanding, this can be used for loops. This can be used for loops where the register will keep the counter value 0 and store in a register. And when we use this kind of register addressing mode, its value is getting increased or decreased depending upon the requirement, and after the value can be used or before the value can be used. It's a very simple addressing mode. And next we have the important addressing mode, that is direct addressing mode. So in direct addressing mode, what happens? In this mode, the effective address of the operand is present in the instruction itself. So when the direct addressing mode is similar to immediate mode, we can correlate with immediate mode. The immediate mode contains the actual value in the instruction itself, as we said, add 7. So 7 is the actual value that is ready available in the instruction. But in direct addressing mode, if we say same add 7xx, then one can identify that the instruction itself contains the address of the operand, not the value of the operand. If the instruction itself contains the value of the operand, it is called immediate addressing mode. And here in direct addressing mode, the instruction itself contains not the value of the operand but the address of the operand. So using this address, when I say address of the operand value definitely would be stored in the memory, in a particular memory location. So just take this address, place in the MAR, memory address register, perform a read operation, memory fetching from the memory, or read operation, place that operand value in MDR, and from MDR place in any one of the register and proceed with the operation execution. So this is called direct addressing mode. See, direct addressing mode, direct in the sense the address of the operand is directly available within the instruction itself. In case of register indirect addressing mode, previous case, the address of the operand was present in the register. But here, in direct addressing mode, we can get the address of the operand directly from the instruction itself. This is called direct addressing mode. So this is about pictorial representation of how direct addressing mode works. So here what happening, for example, the instruction is, what is the instruction? Add R1 with 4000. 4000 is not a value, it's an address. So this is the notation for mentioning the address. So in this 4000 is an effective address of an operand. Note that effective address is the location where the operand is present. So this is one operand, the register value, and the second operand is some address of the operand. So take that address and store it, perform one memory read operation or fetch from the memory, place in the address register, from MAR go to operand. So the address of this 4000 is now stored at, this is the address where the operand value, let's assume 10, is stored. Place that 10 in MDR, memory data register, and from here MDR place that in particular register value and proceed with the addition operation. So this is called direct addressing mode. So this is an opcode part, this is an address of A. And next is indirect addressing mode. So it is not register indirect mode, it is just indirect addressing mode. So in this, the address field of the instruction gives the address where the effective address is stored in the memory. This slows down the execution as this includes multiple memory lookups to find the operand. Remember when we discuss about direct addressing mode, the advantage is that address space is not limited, but the disadvantage is that you need to require one memory fetch. But in case of indirect addressing mode, we need to have two memory fetches rather than a single one memory fetch. We have two memory fetch operations are required. not the single memory fetch. And of course, the advantage is that address space is not limited to memory. So this is an instruction, this is an opcode, this is an address. Let's assume the previous, let's take the same previous example, 4000, but then it becomes direct addressing mode. Since it is the indirect addressing mode, add two brackets. So with this, what happens? So it is the notation specified in the instruction, but you will differentiate the direct and indirect addressing mode by using the bits, addressing mode bits. So what happens? Take this 4000, go to memory. This is the 4000. So place this 4000 in MAR, memory address register, and in memory, let's assume this is some 2000. So this 2000 is being stored in the 4000 to now. This is 4000. So in 4000, what is being stored means some 2000, that is address. This is the 2000 where the actual value is stored. First place this 4000 in MAR, go to memory, fetch 2000 in MDR, and again place this 2000 in MAR, go to 2000. Now the MAR contains 2000, and now the MDR contains the actual value of 10. So this is how operand is fetched. Then what is the advantage of this indirect addressing mode when compared with direct addressing mode? Means it is used to the length, when we want the length of the operand to be limited. So if we require two memory fetch, two memory read operations, yes, of course, but the advantage compared to direct addressing mode is that the addressing space is still more increased. That is the one advantage, but the disadvantage is that you require to perform two memory read operations. Next we have displacement addressing mode. In this content of the indexed register, this is a very important addressing mode. In this mode, the uh, reg- content of the index register is added to the address part of the instruction to obtain the effective address. So here we make use of a special type of registers called index registers. So the effective address is address that is mentioned in the register plus the index register and the address of the instruction mentioned in the instruction. So in this, see, this is an instruction which contains opcode and register R and address A. So this go to register R which contains some address, take this part of the address, add these two addresses to get effective address. So let's assume add R1 same 4000. So R1 contains the address like 20. Now add 20 to 4000, you will get 4020, that is the actual address of the operand. So this is called displacement. Here we make use of a special type of registers called index registers, and this is especially used to access array elements. So remember how array works. So the array works if array elements are stored in memory with contiguous memory location starting from 2000, 2001, 2002, 10, 5. So this base address is mentioned in the instruction, and this index register contains the index 0, 1, 2, 3. So if I want to access this third memory location, that is 2, add 2000 plus 2. Mention 2000 in the instruction, and the register contains 2. So next time if you increment the register value, it is incremented to T3, we get the next array elements. Next we have relative addressing mode. It is version of the displacement addressing mode. In this, the content of the program counter is added to the instruction. See, in the displacement addressing mode, previous addressing mode, we use the content of the register should be added to the address part of the instruction. But here we are adding the address part of the instruction to the content of the program counter. It is to obtain effective address, and this is especially used for function calls. See, the when we call a function, we store, before calling a function, store the program counter value somewhere else, and uh, the new program counter value is loaded, and the address of the instruction contains the address of the first instruction in the subroutine, and so the program counter value is added to this subroutine address, and the increment the program counter value so that you can fetch the next instructions in the subroutine. So this is the effective address. PC is a program counter, the operand a in a cell away from the current cell. Next we have base register addressing mode. It is again a version of displacement addressing mode. This can be defined as or a is the displacement, or holds the pointer to the base address. As I said, it can be used to access array element. And we have stack addressing mode. In this mode, operand is at the top of the stack. For example, add. This instruction will pop the two items from the stack, add them, and they will push the result back to the top of the stack. This we discussed when we discussed about zero addressing mode. If I have stack A or B or the top of the stack, when the instruction is simple add, then fetch the two values, add, and again push the result back into the stack. So basically this works by using stack. So these are about different addressing modes.